There we go. Just in case Marilee is gonna come and she has to take off early. So, hi everyone, you almost made it to break. Good job there. Um, let's see, who are we? Are we waiting for? Karia's not here. And I don't know if we're expecting her. Okay, well, I'm gonna get started. Misa, are you ready with the goodies? Okay, cool. Okay, so I wanted to talk about the House of Pressure today. As I mentioned in email, I don't usually talk about it in Sapphires, but we're using it, and so I thought I'd loop you in as well. I think of Sapphires as as kind of a platform from which we could expand to further the cause of quality in the indoor environment throughout the entire world, etc. So, and the House of Pressure is part of that vision. Now, I also want to acknowledge that it does not belong to me. It was built by Paul, and so I feel a little bit I, what's the word? I feel like I'm butting in if I talk about it. So just acknowledging that to start off. First thing I wanted to bring up is I mentioned before that we would like to have a Healthy Housing Coalition meeting here in Fort Collins. Those occur every month, typically on the fourth Wednesday of the month at 9:30. And I had invited people to come for February, and I think I've said this before, when Taylor left, I just was not up to organizing 20 people. And so I put it off. But what I would like to do today is get a sense from people of when that might work. Because I need to go back to Jill Bednarik, who's running that, and begin to arrange with her, because they have plenty of scheduling considerations on their side too. So I wanted to clear it with our group. So everyone got their calendars open? And I will let you know when the next ones would be. So the next one is March 27th, and I think that's too soon. And then April 24th. May, why do I have one on May 22nd is the 4th. It's the 4th Wednesday. I'm kind of disinclined to do that just because that's the only break between end of classes and when the REU starts. But I'm putting it out there. The Healthy Housing Coalition team also has some questions because they've got people on maternity leave and so on. I told them babies are welcome, but they might still want. Okay, June 26th is completely out for me, because for other project, that's when our NSF review for continuation might occur. So I'm gonna say no on that one. And then July 24th is open. I personally don't like any of these, but I didn't want to not like them, kind of let everybody, I wanted everybody not to like them. I didn't want to say, well, here's your date, because I don't like the rest of them. August 28th. And September 25th. Okay, so April 24th, May 22nd, June 26th is out, July 24th, August 28th, September 25th. Tell me now if you have days that you cannot, absolutely cannot do it, or they're terrible.
What's the time on this?
It's, they're typically, when they're online, they're 9:30 to 11, I think. But with those people coming here, I would try to make it a little longer, but it would be morning.
Can you say those days again?
March 27th, April 24th, May 22nd, July 24th, August 28th, and September 25th. Now, I don't know if they'd be open to another Wednesday or a different day, but I would rather not just throw everything open and try to schedule over 9 months. That sounds like a nightmare. Okay, so just tell me if you're throwing anything out right now.
The May and July, we said June, May and July ones would be tough for me. The other ones I can make work.
Okay. Will, do you need them again? Okay, April 24th, May 22nd, Christian says that's hard. July 24th, Christian also says that's hard. August 28th, September 25th.
I like the August and September ones. If they're
Prefer between August and September, I would prefer August. September is, I'm not saying not September because it's not impossible, but it's not ideal.
Okay, thanks for the feedback. And I will go back to their group and see what looks good for them. So this is relevant to the topic at hand because it would be really nice if the House of Pressure was operational at the time they visited. So that puts I wouldn't say pressure, I would say motivation on the ARE team.
If that was the case, then later that's right before September. So kind of not in the next few months. During the summer would be great because I need maybe 2 weeks at the most to finish the attic.
So Jordan, work up a little bit.
Say that again.
When you said later?
Yeah, a little bit later. So the earlier dates, I guess what I'm getting at is over the summer would be best for me after the semester. Just to where after the semester I have maybe like 2 weeks, at the most to finish that.
Okay. I hear you.
Yeah,
Okay.
it is actually really close to being, I think, fully operational. There's a lot of things that are operational right now. But to have it fully operational, I don't think it takes a huge amount of time, but that doesn't mean that now is the time that people have to do that work.
Yeah, and it was my understanding that Jordan was off that construction completely, but maybe I misunderstood. We can talk about that later. That's topic 3. So topic 2 is what the heck are we using it for in Sapphires right now? And I was going to show you, darn it. I was going to show you this PowerPoint, which I closed during my class. And it is now being opened. Okay. Sorry, folks, it's happening. And as usual, feel free to ask questions. So can you see that? Is it big enough?
Yeah.
Can't see what I'm showing. Okay, so I want to remind you what we're doing with regard to prediction. the goals for the ability to predict infiltration are in the big picture, we'd like to be able to understand infiltration well enough to develop an adjustment for indoor air quality measurements that accounts for differences in home operations. So we could compare indoor air quality measurements before and after, accounting for the natural variability. But within the sapphires, or within the whole system thing that we're doing, we would like to be able to estimate the flows needed to achieve whole house pressurization. And that means we'd probably like to understand how much infiltration we expect on a 10 to 15 minute time resolution. And I think we said 15 in the proposal, but if I can get less, I will. So just a reminder, what we've shown you during Epic Homes, the causal chain is something like the weather conditions and mechanical ventilation create pressures from one side to the other of the building envelope, indoor to outdoor. And those pressures combined with the leaks in the envelope lead to indoor-outdoor exchange of air. And so we've been looking at this in Sapphire's Epic. One of the things that we have very little data on is how the change in pressure actually leads to exchange of air. So we don't have a lot of data on that. We're not expecting to get a lot of data on that from Epic, and we're going to have a couple of episodes or a few episodes that we'll be able to look at. So Dom, this is where I might draw on you. Dom's done a literature review of what's in the literature regarding prediction and measurement of air infiltration. So there's two ways of doing it. One is measuring the leakage with a blower door and combining that with pressure difference to figure out what the flow should be. Paul, you're also welcome to correct me at any time based on your knowledge of the literature. And so people have done this over seasons and years. They measure homes with a blower door, then they apply weather data, say there should be this much change of temperature between inside and outside, this much wind. And so you can make a prediction over a whole season. You can certainly do it on a 15-minute basis, but there's almost no confirmation of those predictions. There has been prediction at a single set of conditions, and that's been compared sometimes with the other method, which is called tracer decay. And I'll say more about that in a minute, but usually that's only one condition and it's compared with a single tracer decay measurement. And then one study has done a series of measurements on tracer decay for a whole year. And Don, do you want to, is this mostly correct, or do you want to add anything to this?
Yeah, no, that was all correct. From what I've read, and it's been a while since I've looked at it, but yeah, there has been very few uses of tracer decay over long periods for a couple of reasons. Just one, because it's pretty intrusive and can be kind of a hassle for occupants, and it's also depending on the type of tracer, it can have greenhouse effects, and it can be sort of expensive. So yeah, everything you said was correct though.
Also true. So where we are in terms of the science is that this prediction that is commonly done to estimate time varying infiltration really has not been confirmed. Paul, you want to talk about that a little bit? Non-peer reviewed literature?
Sure, I can. So there are really two infiltration models that are used really at all. One is from Lawrence Berkeley National Laboratory. One was developed at the University of Alberta. It's called the AIM2 model. And both of those were somebody's PhD thesis. And if you want the information, you have to get a hold of their PhD thesis. It's not in the peer-reviewed literature. So the only other confirmations that I am definitely aware of are from a company in Seattle that Tami worked for decades ago, and I worked for also decades ago, that did some for some studies for EPRI, Electric Power Research Institute, but those
Well,
also,
I'm about to get into that, Paul, but go ahead.
yeah, so.
So you don't have to explain it because I'm going to.
Okay. Anyway, that there's a little bit of that got outside of project report, but it was still more like conference proceedings, not actually in fully peer reviewed journal articles. And I'm not really aware of much else that's out there.
Yeah, and that's why Dom did the lit review, because we said, well, this can't possibly be the case. There must be something else out there, and it appears that there's not. The series of measurements was done by, dang it, remind me, Dom. I'm blanking on it now, but the people at NIST who were measuring a townhouse, and so they did tracer gas decay, like squirting a single injection like every 6 hours for a year. And so anyway, there's been very little confirmation of this in the literature, except for, as Paul says, right? We know that it is possible. So showing you here is out of the, the bowels of project reports, predicted and measured infiltration. So the bold line is a prediction, the way we're doing it now, pressure predictions, leakage, and the light line is infiltration measurement using a tracer gas. And so it is out there and it is possible, but it's never appeared in the literature. And you can see this is 30 years old and nobody's repeated it. And I was one of the authors on this study, but it was a very long time ago. And so you can really only find it if you're looking for it. Again, as Paul says, you need to go into the ecotope bowels and know that you're looking on their publication list, and you can eventually find this. Anyway, so bottom line, we know it's possible, but nobody's done it. So now, what are we going to do in sapphires? Acknowledging that this kind of thing is not out there, we're not going to do it in the field study of the 16 homes. As Dom said, occupants don't really want to sign up for having gas injected into their homes. It's also intrusive because you need to bring cylinders of the tracer gas that you want. This is not the kind of thing that engenders trust. And so we do want to demonstrate a real-time match like this for homes that are friendly. Me, my friends, Will's friends, right? And that will justify the use of the pressure-only measurements in the field study if all goes well. So recognizing that this real-time prediction has not occurred or not been brought forward, we'd like to show that it is possible, say, yes, you can use pressure measurements and here's why. And so that's why Misa and I are working on this tracer gas measurement technique. It's not something we're going to bring to the field, but it is something that we think needs to be done and demonstrated before we rely on the pressure only measurements in the field study. Does that make sense to people?
Yes.
Okay, so the most common method of measuring air exchange is single injection. So you do one squirt into a house or a room, and then you get a decay rate like this. So when I said that somebody had published a year of measurements, they did a single squirt like every few hours, measured the decay rate, and then reported that and showed that it changed, but they did not relate it to any weather conditions at the time. In order to do what we're talking about, which is real-time infiltration, what you need to do is constant injection. And so here's the equation for the single injection. You assume that the decay rate is constant. You extract this value of K out of this exponential that you can see going down. And then you say, there's the decay rate. But if it is changing, then you need to account for that in the equation for the concentration. So S is the source, you have a continuous source instead of a squirt, and you allow that value of decay rate to change with time. The math, the extraction math to get the infiltration rate at the home is harder. And people typically don't do it. But that is how we did that other study. So because we're kind of in the zone where it hasn't completely been demonstrated yet, we're demonstrating this in house of pressure. So we're doing one chamber, that chamber there, the very end one way over on the right, closing the door. And Misa, you can maybe talk about this a little bit. We're doing a single injection first. Do you want to, and I can stop my share and then you can show the kind of results that you're getting.
Okay.
You should be able to share. Yeah.
Can you guys see the graphs? Okay. So yeah, I've been making tracer gas measurements in the house pressure here in the area lab for the past couple months. Essentially trying to track the leakage out of the room and house the pressure under typical pressure difference conditions. So I've been using a methane argon mixture gas and injecting it into the center of the room on the far right of the house of pressure for a period of about like 2.5 minutes at a rate of around 100 CFH or 47 liters per minute. Then just trying to track its decay over time, usually an hour and a half. And so that's what these center like red graphs are. We've been experimenting with the mixing, trying to tackle that issue to make sure things are properly mixed. So these are different calculations that have been made with 3 different fans. So as you can see, there's a lot of like jumping around, but that's just because of me. One of the ways that I was trying to look at the mixing, making sure it was properly mixed in the room, was using different tubes that were placed in different areas of the room. So 2 upper, 2 lower, and then 1 in the center of the room, kind of close-ish to where the injection of the gas was in the room. And so for me to be able to differentiate between the 2 changes, I kind of switched this tube distributor thing that we've been using to switch between the tubes and letting it suck in ambient air from AIRI because in the ambient air the methane is a lot lower than what it is in the room. So that's how I'm able to get these different colors from the overall concentration decay of the methane. So that's what these are. The different colors represent different tubes across the room: front right lower, front left lower, front left upper, front right upper. And so from this, we're able to calculate the different flow rates that each of the tubes have and the overall what's it called, flow rate of the graph just from the log of the methane concentrations.
Can I have a question? Is it okay to ask now, Tammy, or
Of course.
I'm not sure. So I think I understand the middle and the right plots. Those are partially because those are familiar to me, but I don't know that I understand the purpose of the different tube trials that you're showing on the left. Could you explain those again?
Yeah, so the reason that I was trying to or using different tubes across the room was to kind of help ensure mixing was occurring properly in different points of the room. So that's what these tubes are in reference to. They're placed in different locations in the room that we're using for the methane decay. So that's what this is. I don't have a picture of the tubes in the room. I probably should have included it, but these are the different locations that the tubes are in the room that we're testing in. Here.
So we're just trying to make sure the room is well mixed, right? Ellison, so
Yeah.
switch between different. We're also, yeah, go ahead, Misa.
Yeah, so the tubes are placed in each of the four corners here on the front
Mhm.
facing wall of the room. And then
Yeah.
there's in the center, kind of close to where the methane's being injected. So this is where the fan is placed in the center of the room.
Mhm.
The methane injection, I kind of attached close to the back of the fan.
Yep.
And then the center tube is like right behind here. Not exactly like in where the injection is happening, but close enough to the center of the room. So that's what the tubes are. Just to kind of help validate that mixing is occurring in the room.
So what it would look like if that weren't the case is your plots bar on the left would be sort of have step function changes, right, between those colors?
Yeah, so like initially one of the issues we were having, it had to do with the machine that we were using to kind of like switch between the tubes. So this is the setup that we have, right? This is the Picaro, this is what actually reads the concentrations.
Mhm.
And then there was this machine thing that we found in an area that we've been using to kind of switch between the tubes. Um, because before, like initially, like I was having to like switch the tubes connections directly to the car, and that was taking a long time. So this makes it a lot easier.
Mhm.
Um, and originally, the solenoids were in the box, but they were just kind of like pressed together. They weren't really like connected properly, like with unions or anything.
Mhm.
So this is what we were getting at first. Where's the graph?
Yeah, we thought we had really bad mixing. And
Yeah,
so
so
we can show you something that
Okay, so
isn't
yeah,
really,
okay,
like,
this
it
is
would
super
without-
helpful, because that's what I would picture if you had bad mixing.
Yeah.
If I understood the figures on the left, so this is, thank you, this is very
Yeah.
helpful. I appreciate you going into detail.
Yeah, so this is what we were looking at. And so like
Yeah.
we were trying to like problem solve and we were like, why is this happening? It ended up being because of the tube distributor being just pressed together instead of actually connected. And so that's how we were able to go from there to these trials that we actually had reliable data from.
Mhm.
Um, yeah, and so we were testing with three different fans, right? We had a bigger fan, a small fan, and then like a medium fan. The small fan isn't oscillating. It's stationary. The big one does oscillate, and then the medium one or smaller medium one oscillates. And so that's what these different trials are for. So this is the big fan oscillating. Um, and this is the ACH we were getting with each of the fans. Based on like the curves over here, the slope of the log of the methane decay. And they're all very, very variable. Why? I have no idea. Um,
Well, let me, slightly disagree with you, Misa. On the same test, they're not variable. We're getting very similar results from the different sampling locations in the room. Yes,
Yeah, 'cause each of those ACHs is the average for that day plus or minus your variability
it's the average for that test. Yeah.
for that test, sorry.
this average value, or what are
I
you?
guess I was looking at the ACH value where you have a plus.
Okay. No, this is the ACH is just based off of the slope from the um log methane decay graph. Um, and then it's yeah, because it's in units of 1/2 so I just converted it to ACH.
Mhm.
Yeah, so this is what we've been doing. These are the results that we've had so far. And these have been single injection tests. Next step is to go and try and figure out the constant injection. We have yet to what's it called? do a bunch of constant injection tests, and get like reliable data from. So yeah, that's what I've been working on.
Yeah, thanks, Misa. You can, so you can see the kind of decay tests we're doing. We're also, as you can probably see, testing like mixing schemes or like the equipment that we would need in a house. We're trying to make it as small as possible, but still get mixed. Okay, so I'm gonna put my slides back if that's okay, Lisa.
Yeah, you can do that.
Cool. Does anyone else have questions for Misa?
Can I ask one more? Sorry.
Of course.
Are you getting air change rates that make sense to you for the house? I mean, they seem really reasonable to me.
They seem really high.
I'm impressed. Like, I feel like they're very reasonable numbers and they look good, but I don't know the house of pressure so well. So are they on par with what you were hoping for?
Well, so
Like,
can I, maybe if I can, you can answer Misa, but then I wanna, that's part of the next discussion too.
Yeah. So for the methane injection, the calculations are based off of an air change rate of 0.5. So that's kind of where we're getting like the flow rate and the injection of the methane, how much we're supposed to actually be getting. So this isn't matching up with
Okay.
what
No,
was
but we
expected.
just did, we just thought maybe it's 0.5. So I don't think we expect that. When we did the experiment design, we said, oh, maybe it's 0.5, and then it's not,
Okay.
right? So yeah, that's not as expected. So we're doing this single injection. The next thing we want to do is do a continuous injection, which is, as mentioned, a little harder to interpret. So you do a constant release, and then you'd have a constant source, not a, or constant concentration. And we want to get out of that the same rate as the single injection. So we would run the decay test and then run a constant test and hope to get the same answer for the air exchange rate. And then the ultimate goal is to be able to do a step change in the ventilation rate, like turn on a fan and be able to extract those two ventilation rates from the concentration signal. But then getting to your point, Ellison, I think what would be helpful for us in the house of pressure, which I realize is also not part of its original design, is understanding the chamber air exchange rates. Like, I was surprised that they're 1.5 to 2 or 3, because that seems high to me. And there's like, I can't tell what the driving force is. I have no idea what the driving force is. And they vary. They are pretty constant over a test, but they vary day to day. And I don't understand that.
You measured the pressure difference across the room.
We measured it yesterday and there's like no pressure difference. There's 0. So I would love your advice, Paul or Jordan or anyone who is thinking about this. I'm thinking there's not much temperature difference between indoors and outdoors.
I can't speak on what the driving force could be, but I do know that their manometer lines run throughout the whole thing. So you could get all that data. You would need like 8 manometers, but yeah, that is very curious why it's changing like that, or why there is such an exchange.
And we just measured it with not the house of pressure manometer, just with one of our field manometers. So then I think we also don't understand how it's been designed. And this is, I'm sure somebody understands how it's been designed, especially Jordan and Paul, but we're aware that there are damper ducts and so on, and we don't know what they're for. And it doesn't matter what they're for until we don't understand what's happening. So I'm suggesting maybe that the team could use a better understanding of being able to work with that facility. And then we don't know, I know it's been designed to show airflows. And so there's probably been some consideration of what the airflows are, but we don't know what they're supposed to be, or if the flow rates in and out of different rooms have been confirmed. Because as I mentioned, and again, this is very specific to what we want to do. And not at all specific to how you want to train with it. We would like to be able to understand what the flow rate would be so that we can use the tracer gas to measure a change and then see if it is reasonable.
So,
Yeah, go for it. This is the last slide I have, so feel free
Yeah.
to.
so there are 3 rooms in House of Pressure, but we should really look at it as there being 6 zones. 3 of the zones are those 3 rooms. 1 of the zones is the crawl space, 1 of the zones is the attic, and 1 of the zones is outside. Now, right now, the attic isn't sealed off, and so the attic and outside are not differentiated. So right now, we have 5 zones, not 6. When we have this all buttoned up after the couple of weeks or so that Jordan was talking about, it will be 6 zones because the attic will be its own zone. The dampers, so there are dampers that can allow any zone, or dampers or doors, to allow any zone to be more or less connected via airflow to any adjacent zone. So, for example, there are dampers that allow us to go between each one of the 3 indoor rooms and the crawl space, each of the 3 indoor rooms and the attic or outside. Then, of course, we've got doors and windows to open them to outside as well. There are dampers or some type of openings to allow the crawl space to be connected to outside, the attic to be connected to outside. We also have dampers within the duct system because duct leakage changes the pressure dynamics as well. So by being able to change the duct leakage from tight ducts to leaky ducts, having it be on the supply side versus the return side, having it be some or more, allows us to really change the pressure dynamics of the house. And then depending on what doors are closed with it between the 3 interior rooms, that can change the pressure dynamics. Then we also have like exhaust fans, kitchen fan, bath fan, which will change the pressure dynamics as well. So what we're really trying to do in there is be able to come up with a whole wide range of pressure scenarios, pressure regimes, where you can have, like, for example, we could have the room that you're testing in be pressurized or depressurized, and the room next to it be differently pressurized or depressurized because you've got doors closed and what dampers are open or what leaks are there in the ducts. Do you have a fan on? That sort of thing. In terms of flow rates, well, let's see, let me step back. We did do a blower door test on the entire house. I don't recall that we did a blower door test on individual rooms, but we did do it on the entire house. The leakage for the entire house is similar to leakage in existing houses, which means at some level it's leakier than existing houses because it's smaller than existing houses. And so if we still have that same blower door reading on a smaller house, that means it's a leakier house in some ways. Part of that is because the attic hasn't been sealed up yet. But I feel like that's okay because I like to have, if I'm training people, I like them to see numbers that are like what they're going to see in the field. So I was happy with that. Let's see. So, but in terms of more specific flows, I have not actually been focused on the exact flows from one room to another or between zones or anything like that. What we want to be able to do, and I don't know that we've really gotten to yet, is, I don't remember, Jordan, correct me if I'm wrong, we want to be able to have it be where when you change flows, you can eventually change the flows enough that the fog that's going up the plastic flue starts coming back down and fills the room. And I don't really care, is that at 100 CFM, 150 CFM, 200 CFM, as long as we have enough flow in the house that we can have it be going the right direction sometimes. And then when you do certain things like turn on the kitchen range hood, all of a sudden it goes the other direction.
So you want to be able to demonstrate the principle, but you don't so much set the flows precisely to achieve it. You just make them big enough that it happens.
Right, that's right.
Yeah. Yeah. So I guess, I'm sorry that we kind of crowded in on this very useful tool, but I
We
do
believe in
think it would be
sharing.
super. What?
I believe in sharing.
Oh, good. Okay. I do think it would be super useful because I haven't ever seen this, the constant concentration or the constant injection math be tested, right? Like when we did it in those reports, really, I have no idea why it worked. It's amazing that those reports were published because we just went to the house, started dumping tracer gas and measuring it, and nobody's done it since. And so I feel like gaining this confidence in the safety of the lab would be great. But I think there's currently a disconnect between our understanding of the house of pressure and your understanding, or yours and Jordan's understanding. And so, for example, yesterday, like a boot fell off of the floor, not registered, but the hole down into the crawl space. And I'm like, I don't even know if I would put it back right. Right. So Misa just taped over it with cardboard. I don't think that's the kind of treatment you want for the house of pressure. And so I think maybe some greater understanding of at least us, or possibly the whole team, of how it's supposed to work would be, it'd be helpful for what we're trying to do. I don't know if it would help you at all or just take your time, but I think it could potentially be a really useful analysis tool, an experimental tool beyond what you had envisioned for it.
So I'll make a couple of suggestions. Well, my first suggestion, I think, isn't going to work. My first suggestion was going to be that we use the call after after spring break, use that time and just do stuff there, because what you have on there is Healthy Housing Coalition planning. And if that's not
No,
until
we can't do
August,
that. I can move it because Aaliyah won't be here yet.
yeah, it says Misa will be out, so.
Oh, Misa's out. Shoot.
So that doesn't work. Otherwise, I would say we could do that. So my second suggestion is, I think a lot of us are not around next week. But Misa and I are no longer going to Chicago the first couple of days of the following week. And so we've got a little more flexibility, and maybe we should just all get together and run through some of this, or anybody who wants, not all of us. I think, at least maybe Misa, Jordan and I can get together, and anybody else who wants to be there to troubleshoot some of these things and try to figure this out and really see all of the things that it's doing now. Have an hour or two on one of the days, the week of the 18th.
Is there, yeah, I can try to arrange that. And then I just want to be conscious. I know that Jordan needs to be on other things for Sapphires right now. So I just want to make sure that, like, if we draw on Jordan's time, that it's acceptable.
Yeah, I think getting the system up and going, like making sure that the knowledge that he has in terms of the assembly and all that's time well spent. Because I do think he'll interface with it again when this test cart that we talked about last week is up and going. We just shifted him off of the construction now that he's a grad student as opposed to an hourly student. So knowledge transfer, all supportive of, 100% supportive of. And I don't know why my camera stopped working, so I apologize why it went black.
Okay, so does it look like we try to find some time together? And Paul, you think we need we probably need more than an hour, like an hour and a half or 2 hours kind of thing.
I would prefer to schedule 2 hours and then be able to leave before we use it all up. I think if we schedule an hour, we're gonna get to the end and be sad.
Yeah, okay. Okay, and then, I do think that having a schematic of how it's supposed to work, or of the connections that are supposed to be there, would be really useful. Is there one available?
Jordan, you created something like that, didn't you?
Yeah, there is one on Miro right now that you can kind of look into and then click on the link and then you go into Inkscape, I think it's called, and you can start like shifting through the layers, whether it's HVAC, electrical, couple of
Oh, that's nice, okay. So I'll chase you down for that.
Yeah. And when you mean connections, are you talking about like kind of how you described how the register slipped out down into the crawl space? Are you talking about you want like descriptions on how those connections and fittings are made? Or are you just talking about like a system as a whole, like how is room to room, damper to damper connected?
Yeah, system as a whole, like I don't know what's connected to what. That makes it hard for me to think about why the airflow might change.
Yeah.
Or should it have changed if the thing fell off down into the crawl space? Yes, I think it should have changed.
Yeah.
It
So
also makes,
the Inkscape, with that should guide you through it because every damper, every blower is in there. And I can walk you guys through that anytime you
Okay.
like.
that might be
another-
useful.
Yeah, one of the things that I did just think of is there's those acrylic pipes that are going up and connect all three rooms that are clear acrylic. Those are open just straight to the window. So if there's any wind outside of the window, if there's like a real temperature difference from the inside to the outside, there could be a huge amount of air exchanging because that acrylic pipe is just completely wide open. And if the
The clear
temperatures,
pipes are going to that small pipe that goes out the window.
yep, and they're totally unrestricted. So that could draw in and push out a ton of air. Like what I think Paul and I, we found a 200 CFM difference when that pipe was
Okay.
plugged versus when it wasn't. Does that sound right?
Okay.
CFM 50, not just regular CFM. So that's with the blower door.
Yeah, or it was 20 or 200. Whitney probably
I
has-
think it might have only been 20. I don't think it was a lot, but the blower door is really looking at kind of square inches of area. It's although if it was at 50 pascals, you would think it would only be pulling 20, but if 50 pascals is a 20-mile-an-hour wind. And that room is not very big, so an air change in that room is not a lot of flow.
No, it's not, but it, so we could put a hot wire, in like below that clear tube and see if the speed was changing. Oh, Whitney has numbers. Oh my gosh. Okay. So maybe so the last thing that I didn't really get to, and Paul, I know this is probably in your head, but given that we keep using it, I also see it as a resource. And even though it may not, or some of the development may not be done under Sapphires, I'm curious about, like what how you see it being finished. Like as we think more broadly about explorations we could do about indoor air quality, are there ways that it could be used and made useful, or are there things you wanted to do with it beyond training? Because I'm already thinking of evil plans, like, we really have a hard time with the difference between gases and particles indoors to outdoors, right? And so even though it may not be representative, it's a place we could explore. So I guess I'm just curious about how you see it playing into the broader vision.
So, and then
series
from a training perspective, it's kind of over designed for a training perspective. From a training perspective, there are like 3 or 4 things I want to show, and we would be able to do those 3 or 4 things with probably a quarter of the dampers that we've got. But when we're designing something, building something, it's like, well, let's build in as much functionality, possibility as we can. And so that's why we've got these things all over the place, so that we have, it's not exactly infinite scenarios, but it's a lot of different scenarios where we can have, you know, two of the rooms open to each other, the other one closed. And then within that, we've got all these different options for duct leakage on one side or the other, fans going, fans not going, open to the attic, close to the attic, open to the crawl space, close to the crawl space. Crawl space is vented to outside. We can just do all kinds of things. And I see us being able to use it as a research tool to cover a wide range of possibilities, to really, in a lab setting, test all kinds of things, whether it's particles or gases or whatever. We could put in electric space heaters and create our own delta T that should then have some of that driving force, that's without having to have a fan make that, or wind blowing on that tube, if Jordan's speculation is correct. So I see us as just, you know, we've got probably hundreds of different combinations with everything that we've got in there. And so we could really, yeah, kind of, we've spent a long time mapping out what the pressure regime is for every possible combination. And then what would we want to use each for? I'm not saying we should do that, but I would love to see it get used for research when it's not being used for training, which will be most of the time.
Okay, so I guess maybe the thing that I wanted to bring to you and to the group is how can we help, or what should we think about maybe outside of sapphires that would allow it to move forward? And I realize that Jordan has a certain amount of bandwidth and maybe get to it in the summer, but I'm also really interested in knowing how we can support the development of that facility, even if it's not officially under sapphires.
So it's not to
Well-
say, and Dr. Larange and I had this conversation earlier today, there's going to be a moment where I kind of need to switch modes when these parts are in order, maybe 2 or 3 weeks. So if this is something we want to get done, I would be more than happy to just, you know, crash the schedule and get whatever we need done as soon as possible, or as soon as you guys want.
Well, I also want to acknowledge that what's under Christian is like also a lot of stuff with urgency. So for preparing for the field experiment in the fall. So I'm not signing you up, Jordan. I'm putting it out there that I'm open to discussing how to move it forward. And so that it can be a research tool. Okay, so on the table is, we need to find a couple hours to play with the house of pressure. And maybe raise your hand if you want to be in the room for that. Dawn, Will, Paul, Misa, you're tapped already. Anyone else?
I do as well, but I can't get my camera to turn on. So I
Okay.
am raising my hand, I promise.
Oh, okay. Yeah, your dark
We,
hand.
we would be well suited to have Jordan in the room, since he has put together so
Sure.
much of it.
Okay.
Yep, I'll be there. And it should be worth noting that right now there's a misalignment between the fog machine and the vents that vent. So I need to 3D print like a housing that goes on it, because our fog machine is so unaligned, and I had nothing to do with it, that it's kind of it just doesn't work. So I might need to CAD up something and 3D print it before we do all this. Otherwise, it's going to be.
Okay.
But
Yeah, and it
I
doesn't
just-
have
I
to
just need
be,
a day.
doesn't have to be perfectly functional in order for us to learn about it. Okay, cool. Well, thank you, everyone. Thanks for humoring me. More on tracer gas to come. Okay, well, everyone have a great break. We're off next week for break, so have a really good time, whatever you're doing.
Thank you.
if it was a catch-up week, I hope you catch up.
Tammy,
Bye, everyone.
do you have time after this?
Sure, I'm supposed to meet with Misa, but I can talk to you for a few minutes. Yeah, you can just, okay, I'm gonna stop the recording.